Okay, today's lesson is 11-2, probability distributions. And I am trying to tackle the whole lesson this time, so just brace yourself. It's going to be a little bit longer than those first two that we've had. Okay, to start off with, we have to talk about two different kinds of variables. We have what is known as a discrete random variable, and that is one that can take on finite or countable number of possible values. The example that you have here is number of car accidents per year. You can see the numbers that they have. I can't have half of a car accident. So since fractions don't make sense with car accidents, it's a discrete variable. On the other side, a continuous random variable is one that can basically take on an infinite number or possible values within a specified interval. When you're driving, the number of miles that you're driven, does it make sense to say that you've driven 2.5 miles? Absolutely. So if fractions make sense in the context of the problem, know that it's continuous, and if they don't, then it's going to be discrete. So here's some examples. Here's some examples down here. X represents the number of time it takes to serve a fast food restaurant customer chosen at random. Okay, so the variable is time. Okay, does it make sense to have a fraction represent time? And it does. Of course, we can have 1.5 minutes. So that's an example of a continuous variable because time can be a fraction. Okay, the next example says X represents the attendance at a randomly selected monthly school board meeting. Okay, the variable is attendance. Does you take attendance by counting the number of people? Can you have half of a person? Well, no, you cannot. So it is a discrete variable because it can't have a fraction of a person. Okay, the next thing we have to talk about, probability distributions. And basically, it's a distribution of probability values. Okay, each value of a probability, remember this is pretty basic, but each value of a probability has to be between 0 and 1. And when you have a probability distribution, you're looking at all the different ways that the events can happen that are in that sample space. The sum of all those probabilities always has to equal 1. Oops, I didn't mean to do that. Remember, this little symbol here is the sigma, and that means that you add up all those possibilities. So here's an example. A car sales person tracked the number of cars she sold each day during a 30-day period. Use the frequency distribution of the results to construct and graph a probability distribution for the random variable X, rounding each probability to the nearest hundredth. Should have mentioned it there, but I didn't. Okay, so this is your data value. Cars sold X. That's your data value. They either sold 0 cars, 1 car, 2 cars, or 3 cars. Okay, on 20 days of the month, they sold 0 cars. On 7 days, they sold 1. On 2 days, they sold 2. And on 1 day, they sold 3. So hopefully you can tell that means your frequency, the bottom row, that's a total of 30 days for the month. But we have to go get the probability, the probability that represents each of those frequencies. So we're going to go find, and we're going to take 20 and put it over 30, and that's going to give us 0.67. We put 7 over 30, and we're going to get 0.23. Put 2 over 30, you're going to get 0.07, and 1 over 30 is going to be 0.03. And these things all add up. So this is the example of your probabilities that represent all the events in your distribution, okay? And the key is all those numbers have to add up to 1. So what does the distribution look like? It's going to be that, okay? So this is, you can see that what's on the bottom, cars sold, as we just said, 1, 2, 3, 0, 1, 2, 3. 0 was that highest probability. My probability is 0.67. So the highest number that I have up here is 1. And that's going to be 0.1. So that first tick mark is 0.1. I don't know why it's flashing. I don't know if that's flashing for y'all or not. But anyway, that's what we've got. So that's what your probability distribution looks like. Now, what's important is you've got to be able to take the mean of a probability distribution. And it has a lovely formula. And that is you take each data value and you multiply by its probability. and then you add them up. So what does that give me? They want us to find the mean of the probability distribution you constructed in the guided practice 2 and interpret the meaning in the context of the problem. Okay, so the data values, remember up here, that first row right here, those are my data values and those are my probabilities. And what our formula just said, I can't get it on the same page, but you're taking each data value, multiplying it by its probability, and then add them all up. So what that looks like, we have, where is it? Mu data value probability plus data value probability plus data value probability plus data value probability. And that's all we had, 0, 1, 2, 3. So when you add all those up, you get a mean of 0.46. So what does that mean? 0.46, you could think of that as rounding to 0.5, which is half. Okay, that's the number of cars they sell on one day. But it doesn't really make sense to say it like that. So really what they would say, instead of half a car a day, they would say that they would sell one car every 2 days. Okay, now the other thing you have to do, this is the doozy of the problem with the formula to calculate the variance and standard deviation of a probability distribution. Here is your formula. Okay, that is the formula. Notice right here, this says sigma squared, okay, and that is the variance. Okay, so how am I going to find the standard deviation? You need to remember that the standard deviation is the square root of the variance. So we're going to use this formula, and then we're going to take the square root at the end to find our standard deviation. So we're using the same problem with the cars, okay, and this is the formula broken up into pieces. Actually, I should have talked about it earlier, but I put it right here. Round your answers to the nearest hundredth. I need you to know that that means you don't round to 2 places until the end of your problem. Okay. If you want to know how you did on the list check, it's not going to give you any partial credit. Okay. So if you don't know how to round, it's going to count the problem wrong if you don't give the correct answer. If you submit your work, then we'll go back and look at it and give you some partial credit on it. But I just want to remind you that if it says directions say round to the nearest hundredth, don't round to the hundredths place until the very end. Okay, so here's what this formula looks like. You have a data value, and then you're going to take the data value and subtract the mean from it and square it, and then you're going to, that's the probability. So let's go here. The data values of what we had, 0, 1, 2, and 3. Okay, the mean that we just had from the first, we just calculated up there, was 0.46. So 0 minus 0.46 squared, 1 minus 0.46 squared, 2 minus 0.46 squared, and 3 minus 0.46 squared. These are the probabilities that we got for each one. So I'm going to multiply across. Okay, that's what that's saying. It's multiplying column 2 and column 3, and I get these numbers. Okay, and then what do I have to do? I'm going to add up those numbers. That is my variance. And when I take the square root of that, I get the standard deviation. So notice, okay, this came out, and I didn't know how the problem was, and I'm okay with probabilities coming to the hundredths place. But everything else is to the thousandths place, 3 places. So when I get the final answer over here, I'm going to round both of those to the nearest hundredth. So that's my variance, and that's my standard deviation, rounded to the nearest hundredth. So if you need any help with that, let me know. Okay, moving along. Another application of the probability distribution is something called expected value. And the expected value for a probability distribution is equal to the mean of the random variable. So that's the same thing we've been doing, which is the sum of each data value times its probability. So what's that going to look like for y'all is a water park makes $350,000 when the weather is normal and loses $80,000 per season when there are more bad weather days than normal. If the probability of having more bad weather days than normal this season is 35%, find the park's expected profit. So this 35% is the probability of having more bad weather days than normal, which is what this money. That means I'm going to lose 80,000. So if I lose 80,000, so this 35% is the probability that that happens. Well, the only other event is that we're going to make money. And so what's the probability of that happening? It's 1 minus 35%. So to find it, I'm going to have 350,000 times the percent that it's going to be, the weather is normal, minus, because we lost money, the 80,000 times the 35%. And that gives us an answer of $199,500. I'll take it. Okay, this next thing, y'all, we talked about it in chapter 10. So if you got it in chapter 10, this will be an easy part of this lesson. Okay, a binomial experiment is one that has only two outcomes. The examples that we talked about in class, we're flipping a coin. There's only two choices, heads or tails. And then we talked about rolling a die. Okay, and rolling a die, you would say it's not, because there's more than two possible outcomes. There are 6 possible outcomes. However, if you changed it to what's the probability of getting a 2, then that becomes a binomial experiment, because you either get a 2 or you don't get a 2. So the important thing is there are 2 possible outcomes when you have a binomial experiment. P is the probability of success, and Q is the probability of failure. And remember, N represents the number of trials. So look at these examples and make sure that you know how to identify a binomial experiment. We're going to determine whether or not it's binomial. If it is, we're going to identify N, P, and Q. And if not, we're also going to list the possible values of the random variable. If not, we're going to explain why it's not. So this first one, the results of a survey indicate that 61% of the students like the new school uniforms and 24% do not. 20 students are randomly selected and asked if they like the uniforms. The random variable represents the number who say they do not like the uniforms. So hopefully you can see that these two numbers do not add up to 100%. Therefore, that's not all the choices. So basically, you've got students that could like it, they do not like it, and of course, what's left are those people that don't have any opinion. So this is not a binomial experiment, because there are more than 2 possible outcomes. Okay? 6b, you have completed a test by randomly guessing the answers to 20 multiple choice questions that each have 4 answer choices, only one of which is correct. The random variable represents the number of correct answers. So, is that a binomial experiment? Yes, because how many outcomes are there? There are only 2 outcomes. Either you get the question right or you get it wrong. So, what is the value of N? N is how many questions we have, and we have 20 questions. P is the probability of success. If you have a question, think of one question, okay? If there are 4 answer choices, then the probability of success is 1 out of 4, which makes the probability of failure 3 out of 4. And the last thing is, list all the possible values of the random variables. So how many possible, the random variable represents the number of correct answers. So you can get anywhere from 0 correct answers all the way up to 20 correct answers. Okay, almost done here. Binomial probability formula. Okay, again, we did this when we did our binomial expansions in the last chapter. Okay, same thing. N is the number of independent trials. P is the probability of success, and Q is the probability of failure. Okay, so I give this to you because I want you to see that it's what we've done before, but it's just written differently. So what it looks like, they, instead of using, I'll show you what we did more. We still had P and Q, but we had N, and instead of using X, okay, then they're putting in the formula with the actual how to calculate combinations, which we don't do that by hand right now. But what did we have before? This is our cranberry rule, if y'all remember. So we had an N is the same. We used R instead of X. It's the same thing, okay? And we had A and B, but remember the key was we wrote it like that so it would look like the little cranberry thing. But this one here is the probability of success, and that one is the probability of failure. So again, that's what we did last time. So if you got that in your brain, it just makes it easier. You don't have to remember this different formula. Okay, so look at this problem. In a certain high school graduating class, 48% of the students took a world language during their senior year. 7 students chosen at random are asked if they took a world language during their final year. Construct and graph a probability distribution for the random variable x, which represents the number of students who said yes. Then find the probability that fewer of these students said yes. Fewer than 4. Okay, y'all, this is what you had to do in the past. And I don't really think you're interested in doing this. And then if you had to graph it, that's what our graph would look like, because we graphed each of these probabilities. So the important thing that I'm telling you is this is that problem that you want to use ClassCalc. I'm going to go do it, but what you want to write down is this is going to be an example of a binomial distribution. This is what it's going to look like in ClassCalc. So when you do these problems and you practice the problems for your homework to help you on a lesson check, you want to identify that n is 7. Why is n 7? Because they chose 7 students. And p is 0.48 because 0.48 was the answer of the probability that somebody would say yes. Okay. The other important thing is to read this problem. So I'm going to show it to you. So you have all of these values here. I'm going to go remind you and show you how to do it in ClassCalc. So when you come into ClassCalc, remember, if it looks like this, you come over to the top, you select graphing. Okay, and I'm in that line, so I'm going to come down here to bring up my menu. Move this over so it's not in my way. I'm going to click Stat, Distribution, Plot. And remember, I told you it was binomial distribution. And that brought up, and see, in parentheses, this is telling you what to put in those parentheses. So what did n represent? We said 7, and p was 0.48. So I was using my keyboard. You can tap on your calculator. Okay. I did this because I also wanted to remind you, if you can't ever see it, if you just click on the magnifying glass, made it a little real big there, but you can zoom in. Okay. This is a graph, just like that graph. Okay. Similar, of these numbers. Now look at this. See how that says 0.01, 0.66? Okay. If you go click on this, 0.01, 0.66. Okay, those are the numbers that go along with, I took them all away. Okay, but anyway, we'll go back and get them. Okay, but I want you to know, those are these numbers. So you don't have to punch all this in your calculator if you know how to use ClassCalc. Now, this is where the tricky thing is. You got to be able to do this correctly. You got to read the problem correctly. Find the probability that fewer than 4 of these students said yes. So which of these numbers is fewer than 4? That, of course, is 3, 2, 1, and 0. So on your ClassCalc, I need 0, 0, 1, 2, and 3. And so I'm going to add up 0.283, 0.184, 0.066, and 0.01. And when you add all those up, which is, that's not what I wanted to do, go away. Okay, I'm adding up these 4 right here. And what do I get? I get 0.543, which is 54.3%. So again, easy problem if you practice. So that's what I want you to do in your homework problems, is practice using ClassCalc. Okay, last thing we got to talk about is the mean and standard deviation of a binomial distribution. Much easier than that of a probability distribution. Okay, this is what it looks like. Okay, you have the formula for the mean, just mu is your mean, and n times p, where n is the number of trials, p is the probability of success. Variance, npq. Standard deviation, if you remember, is the square root of the variance, so you just take the square root of npq. So they want us to find the mean, variance, and standard deviation of the distribution we were just working with. So how many trials did we have? We had our formula. How many trials? We had 7 trials, and the probability of success was 0.48. So that means that my mean is 3.36. Okay, my variance is NPQ. So that's going to be 0.7 times 0.48 times 0.52. Why is it 0.52? Because 1 minus 0.48 is 0.52. And I get that number. And then to get the standard deviation, I'm going to take the square root of that, which is 1.32. They didn't tell us what's around. So that is the end of 11.2. Please, my bad. I forgot. Interpret the mean in the context of the problem situation. Okay. So what does 3.36 mean? It means on average, 3 out of every 7, because this was the mean of my trial, 7 trials, 3 out of every 7 students took a world language their senior year. That finishes 11.2. If you have any questions, please email me or schedule a meet. Thank you very much. Hope you all have a great day.